Okay, this is Unit 9 on solutions. Solutions is a big part of chemistry. It's well, let's try to define what they are. Before we even get to that point, let's see where it fits into this whole category of matter. Okay, so matter, as we know, is anything that has mass. If it has mass, you're looking at matter. Okay, so everything around us that has mass is in fact matter. What's not matter? Energy is not matter. Okay, so matter is anything that has mass. And we could further classify matter. We could break it down into two categories. One is pure substances. Pure substances. And the other is mixtures. Okay, on the pure substance side, we have elements and we have compounds. Okay, so pure substance versus a mixture. What is a pure substance? Well, a pure substance, I'll pause it and then come back with the definition. Okay, can we physically separate the substances? If no, then you have a pure substance. And basically that boils down to elements. You cannot break copper down into anything other than individual copper atoms. And compounds. Compounds is H2O. You cannot break that down physically. Physically is the key here. I can't physically evaporate the water and break it down. Now I can chemically break it down. I can break it down into its substituent components, which are hydrogen and oxygen. Okay, but I cannot physically break it down. I could chemically break it down by running electricity through it and then breaking apart the chemical bonds between the H2 and the O2. I can do that, but I can't physically separate the substance. So that's a compound, all right? Then on the other side we have mixtures. Mixtures can be broken down into, or it can be categorized rather, into homogeneous mixtures and heterogeneous mixtures. Now, heterogeneous mixtures are things like dirt, sand, cottage cheese, salad dressing, anything that's not uniform throughout. Okay, homogeneous mixtures is where we find solutions. Okay, solutions fall under homogeneous mixtures. Okay, it's uniform throughout. So if I had a solution of salt and water, there's no way you'd be able to tell there's salt in there unless you tasted it or you ran some kind of chemical analysis on it. It would be completely uniform throughout. Okay, even though it's a mixture, it would be a mixture of salt and water. You wouldn't be able to see it because it would be so uniform throughout. Whereas I could very easily look at cottage cheese and see that there's, you know, some milk proteins in there, there's some fats, and etc., right? That's a heterogeneous mixture. It's not uniform throughout. Okay, so let's go ahead and, well, actually, let me go ahead and define elements versus compounds right now. Okay, so compound is any substance made of two or more elements that are chemically bonded. That's a compound. All right. And then we discussed mixtures. Examples of homogeneous mixtures are solutions. Heterogeneous mixtures, so like I said, anything like sand, dirt, gravel, anything that's not uniform throughout is going to be a heterogeneous mixture. So when we dissolve NaCl in water to form a solution, NaCl is called a solute. Okay, and water is called a solvent. Now I can take salt and dissolve it into water, in this amount of water, and I can keep dissolving more and more. I can dissolve a lot of salt in this. I can dissolve more and more and more and more, and eventually what will happen is I can't dissolve anymore. And at that point, where you can no longer dissolve any more salt into a given amount of water, we say that we have a saturated solution. Okay, and I'll go ahead and I'll just do it like this. You can copy this. Okay, saturated solution. A saturated solution is a solution that has as much solute as a solvent can hold. A solution that has precipitate is always saturated. A solution with less solute is unsaturated. And what is a precipitate? It just means the solid solute. Okay, that's a precipitate. So in the case of the salt water, once we reach the point where no more salt would dissolve in it and it just stays there on the bottom of the container, we call that precipitate. And we know at that point that the solution is saturated. Go ahead and copy that. So now an interesting thing happens whenever we dissolve salts in water. Okay, we get something called electrolytes. And what an electrolyte is this. Well, first of all, what happens is, let me just explain. We get these salts, sodium and chloride. In this case, that's going to be chloride. This is sodium. And we put it in water. And what happens is these water molecules start to surround the positive and negative sodium and chlorides, rather. And what will happen is it actually breaks these salt molecules apart. And when they break apart, we call this dissociation. Okay, it's dissociated from one another. The sodium and the chloride are dissociated from one another, and they're surrounded now by water molecules. And you can see, I know this is sodium because that's a negative oxygen atom, and this must be a positive ion. Well, the positive ion out of NaCl is the sodium. Okay, so that's sodium, and this is the chloride anion. And you can see it's attracted to the positive hydrogen. Anyway, so these salts, they dissociate. And once they dissociate, it looks kind of like this. It'll look like this. You get the Na plus over here, and the Cl minus, and the Na plus, Cl minus, Cl minus. Now it's not all uniform like this. This happens on a scale of trillions and trillions of times. Okay, so what happens is this. It's not all, the Cl doesn't just sit on one side. These things are all mixing around together. So NaCl, and that's solid, dissociates into its constituent ions, which is Na plus and Cl minus. Okay, and once that happens in solution in water, so we say it's aqueous now. So now you've got a mixture of these ions and water floating around. The ions have a charge. These charges can carry, they're good conductors of electricity. Okay, so what is a strong electrolyte? It's a substance that conducts electricity well when dissolved in water. Okay, there you have that, a substance that conducts electricity well when dissolved in water. And what's the theoretical definition? A substance that dissociates completely into ions in an aqueous solution. We'll just say into a water solution. Okay, a substance that dissociates completely in water. Okay, well, that's an easy example. That's NaCl, that's salt. Well, let's look at this example, which is acetic acid. Okay, we know it's an acid, it's got the H in front, and there's the acetate anion. So acetic acid looks like this. It doesn't completely dissociate. What happens is it goes like this. HC2H3O2 goes like this. And that's vinegar, by the way. And that's in water. Some of it dissociates into H plus C2H3O2 minus. Okay, some of it does that, and by the way, that's all taking place in water, so we put an AQ. But guess what? Some of it doesn't. So sometimes these two meet each other again, okay, in this solution, and it goes back this way. It reforms. Okay, oops. Draw a half arrow. Don't draw a full arrow. You got to draw half arrows here. Okay. So what you might see is this. You might see some full molecules of this vinegar, C2H3O2, will still be in there. But then also you get a lot of H plus. Oops. And you also get a lot of the, I'm going to abbreviate this as A. I'm going to abbreviate this as A minus for the acid, okay? You get a lot of A minus over here. A minus, oops. A minus, okay? So you'll have a lot of this floating around, but you also get some dissociation. So what happens? It doesn't carry as much of a charge. Okay, so we could say a substance that conducts electricity a little when dissolved in water. Okay, it's a substance that conducts electricity a little when dissolved in water. Now, a little, we know, is not a technical term, and to be very honest with you, it gets quite complicated. We do that in AP chemistry. We say how much. Well, how much of this stuff actually dissociates? Well, you can calculate it, but for our purposes right now, we're just going to say a little bit. And then what about the theoretical definition? It's a substance that dissociates a little into ions in an aqueous solution. I'll go ahead and write that now. Okay, that's a substance that dissociates a little when in an aqueous solution, in other words, a solution of water. Well, we can guess then what a non-electrolyte is. A substance that does not conduct electricity when dissolved in water and does not dissociate. An example would be, looks like some type of a sugar here, C12H22O11. I forget if that's sucrose or glucose or dextrose. I forget which one of those it is, but let's go ahead and we'll write that. Ready? I'm just going to put this here, and then I'll put it up on the screen for you because my handwriting was so bad. A substance that does not conduct electricity when dissolved in water, and a substance that does not dissociate into ions in an aqueous solution. Yeah. So in this case, let's look at the sugar here, C12H22O11. It stays solid. So whenever you dissolve, that's why it takes so long to dissolve sugar into iced tea, right? Because whenever it doesn't break apart into its ions, it stays a whole molecule, okay? And those London dispersion forces that are holding it together, and it's the fact that it's pretty non-polar, it's just difficult to get that stuff to break apart, as opposed to a polar molecule like a salt that breaks up into ions. So what happens is these molecules of sugar, they stay solid, or they're not solid, but they stay together. Okay, they stay together even though they're invisible. They're still together. They haven't broken apart, and because they don't carry a charge with them, it's very, very difficult in this example to get a light bulb to light up if you ran electricity through it. I'll actually do this experiment for you. Okay, I'll do it with salt, and we can have a look at the various things that affect charge whenever you try to run electricity through these solutions. All right, so now that we're done with that, I think you should be able to do the first part, POGIL 1. So you guys should be able to do that now that you have these terms available to you. You should be able to go ahead and tackle POGIL 1. Okay?